Hi, these are problems 1 through 5 on review day 19. Our first one gives us a graph of f prime, and it says of the following statements which must be true. So again, it's important to know by trying to find true or false ones. This one I'm trying to see if it's true. F has a relative minimum at -3. So this is the derivative of f. The derivative does switch from negative to positive at -3, and that's what makes something a relative minimum. So we would say yes, that one is true. Okay. The graph of f has a point of inflection at -2. So since this is the derivative, f will have a point of inflection if the derivative switches from increasing to decreasing or decreasing to increasing. So the only place that happens is at 0, not -2. So no. This graph might have a point of inflection at -2, but that's not what you were asked, so you have to be real careful there. The graph of f is concave down from 0 to 4. So again, we'll be concave down if our derivative is decreasing. This is the derivative, and this is decreasing from 0 to 4. So that one's true. So 1 and 3 are true ones for that. This next one gives us a lot of information. It says that its position is increasing from 0 to 2 and it's decreasing after 2. Which of the following would be the total distance traveled? And then they give us stuff with the initial position. They give us broken down by parts. We've done enough, hopefully, that as soon as we see total distance, we're thinking absolute value of the velocity. This is the absolute value of the sum. This would be like your absolute value of your displacement, which is not what they're asking. They're asking for the total distance traveled. So E is our choice there. Okay, don't get confused by this other junk. This is what we want right there. Okay. This next one says f is defined for all values in x in a closed interval, but for some reason f does not attain a maximum value. So which of the following statements must be true? So in order to kind of understand this, what it's saying is that it's not saying that it's continuous. It's saying that you can draw your pen, and it's everywhere you go, there's at least a value. It might be a dot here or a dot there, but every place has a value, but there's no highest value. So the only way that happens is if you have a hole at what looks like your maximum, and then maybe the rest of the graph kind of looks like that. This would be a function that's defined everywhere, but doesn't have a maximum value because, if this is 5 here, it's not technically equal to 5, and there is no such thing as the next smallest number less than 5. If you try to do 4.99, I could always throw another 9 in there, and if you say, well, it's 4.9 repeating, that really is 5. So there is no such thing as that. This would be the reason that you wouldn't have a maximum. And so of our choices, f is not continuous. That is exactly what's happening here. F is not bounded. You may not know what that word means, but it just means that to not be bounded means you'd go off to an asymptote. That doesn't need to necessarily happen for this. F does not attain a minimum value. No, it can have a minimum value and still not have a maximum here. The graph has a vertical asymptote. No, not necessarily. The equation f prime of x equals 0 does not have a solution. We could create something. Like I could make this like that, and there's derivative equal to 0. The only thing that can't be true is it can't be continuous. If it was continuous, then it would keep going through here, and then we would have that maximum value. So kind of an odd question. Not much to it now that you see it, but that's where you had to go. This one says that if f prime of x is greater than 0, that means f is increasing the entire time. So when we look at your choices, you can see that this one, this one is increasing, this one's increasing, this one goes back and decreases, this one's 0 the whole time, and that one increases. So the fact that f had to be increasing got rid of 2 of our choices. And the integral from 4 to 7 is 0. So that means if I sum up the whole area from 4 to 7, I should get 0. So if you look at A, it's negative all the way up until 7, and then it's 0 at 7. If it's got to be increasing the whole time, then it couldn't have been positive somewhere in between to... So in other words, it's negative, negative, 0. It's got to be negative this whole time. So its area would be some negative number, not 0. Okay? And same thing here. This one starts at 0 and then goes 4, 6. So its area would have to be something positive. The only one that could give us a chance would be B, because it has some negative and some positive. So there is a chance that whatever this negative area is here, it would be balanced by that positive area there. Okay. Then our last one gives us the graph of f, and it tells us h is the integral of f, so that means h prime is f. This is h prime. On which of the following intervals is h increasing? So h will increase when its derivative, which is right here, is positive, and this is positive from 3 to 9. That's when it's above the x-axis. So E.